Consider the sequence hn, starting with n equals 1, where the nth term of hn is 3 over 2 to the n plus 2 over n times n plus 2. We want to evaluate the series for the hns. So evaluate, which means we are going to be able to, at the end of this, say, this equals 1, or something. I don't know if it's equal to 1. So we weren't just asked for convergence or divergence. They're saying evaluate. So there is a value attached to this. This does converge. So we might run through the list of things that we understand the convergence for already. Things like geometric series. Things like telescoping series. Now, let's take a closer look at our HNs. Are they geometric? Well, I write the 3 over 2 to the n, and that certainly looks geometric. But then it's got this 2 over n times n plus 2. And that doesn't look geometric at all. I'm not seeing powers of n anywhere in there. So it's not geometric. And I can't easily see something that's telescoping. Now, this part here certainly is geometric. Okay. And this kind of looks like, well, maybe just because it's a rational polynomial, not a rational polynomial, a rational function in n, maybe we could do some sort of partial fractions and show that it's telescoping. Okay. This one here, definitely geometric. And what we start with our n equaled 1. So the first term is 3 over 2 to the 1. So 3 halves. And then we can see that our r is going to be 1 over 2. You multiply by a half each time to get the next term here. Okay. So this part, treated on its own, would converge. I wonder if we can get a telescoping sequence over here. Okay. Now somebody was nice, they already factored the denominator here. And there's lots of ways we could do this. We could plug in specific values of n or something like that. I'm just going to, on this side, combine everything. So I'll expand out an plus 2n, or sorry, plus 2a, plus bn, or another way of saying that is 2 is equal to 2a plus a plus b n. And now if I do something like, say, let n equal 0, or just treat these as polynomials in n and compare coefficients. But if we let n be 0, then we get 2 is equal to 2a and then nothing, really. Because when n is 0, that part goes away. So I see a is going to be 1. And then, well, what's our expression? 2a is just 2 now. And 1 plus b times n, but there's 2's over here. If we cancel out the 2's, we see that 0 is 1 plus b times n. This should be true for any n. The only way that can work is if 1 plus b is 0. So b is negative 1. Okay, so returning to this particular part, what have we got? This is 1 over n plus negative 1, or we could say minus 1 over n plus 2. So if we introduce another sequence g, maybe the gn's, as 1 over n, then this is gn minus gn plus 2. This is telescoping. Okay, now how does that help us? So hn can be written as the sum of two other sequences. Now the an's here are the 3 over 2n part, and this is geometric, and it converges. Okay. And the bn here are just the 1 over n minus 1 over 2 plus n, this remaining part here, which is telescopic or telescoping. Okay. And I'm willing to bet individually these converge. Let's sort of show that off. Okay, so we'll show that the sum of the ANs converges. So first term, which is 3 over 2, and then 1 minus the 1/2, so we'll get 3 over 2 over 1/2, 3. So the sum of the ANs converges to a value of 3. How about the BNs? All right, well, how do you tell if a telescoping series converges? All right, if you know your D value, which in this case D is 2, okay, then if you converge, you'll converge to the sum of the first D, in this case at 2 terms, minus the limit of a sum of 2 consecutive terms in the sequence. Oh, this should be G's. Yeah, sorry. It's not the actual sequence B, it's this G sequence that we express it in terms of. Okay. So this is what? 1 over 1 plus 1 over 2 minus the limit, as n tends to infinity, of 1 over n plus 1 plus 1 over n plus 2. As n gets bigger, both of those go to 0. So the limit here is just going to be 1 plus a half, or 3/2. Okay. So both the sum of the ANs and the sum of the BNs converge. And so we know that the sum of the HNs should also converge, because the HNs are just AN plus BN. And if you've got a new sequence formed by pairing up and adding terms of 2 sequences, and their series converge, then the new sequence's series converges, and it converges to the sum. Okay, so in this case, the sum of our geometric series, which was 3, and the sum of our telescoping series, 3/2. And so we can, 3 is 6 over 2, so we get 9/2, or 4.5. Okay? So we have actually evaluated the series for the HNs. 9/2 or 4.5, either or. I'd probably stick with the fraction myself, but I know some people love their decimals.